How you doing? We're going to look at alkali metals. Now, in the periodic table, the alkali metals are the ones, way over here on the far left. We're just going to look at sodium and potassium, and the reason why it's money, and it's also some of these ones further down are so dangerous that, well, they're just too dangerous. What do I mean? You'll see. So, let's get started. Now, I want to start out by showing you that they are metals. Now, most metals are gray. As you can see, the sodium is gray, the potassium is gray. You can see it's a bit shiny where I've cut it recently. And, well, what other properties do metals have? Well, if you hammer a metal, like if you hammer a rock, it breaks. But if I hammer a metal, it doesn't. It just gets squished, doesn't it? Here we go with the sodium. I hammer it. It doesn't break, it just smushes. It's malleable, means you can hammer them. Does it conduct electricity? If you've got a piece of metal like this fork, it should conduct electricity. There we go. So let's see, do these alkali metals conduct electricity? Let's find out. Here's a piece of sodium and yes, it does. That was the potassium and the sodium. Yes, it's also conducting electricity. So you can see they are metals. They bend, they're flexible, we can hammer them without them breaking. They're shiny on the inside. They have all the properties of metals, but you're going to see one way where they're different. So, everybody needs to be very far away. I'm going to start out with the potassium. I'm sorry, we have some members of the crew who are too close. So watch what happens when I put the potassium in water. This is just plain old water, by the way. I heated it up for some reason, but it is plain old water. Watch what happens when I put this in.
It makes smoke.
Now, if I put a coin in a fountain, does it do that?
No.
I mean, pennies are metal, but they don't do that when you put them in a fountain, do they?
They don't. But you need a certain kind of metal.
You do need a certain kind of metal. In fact, I'm actually kind of getting itchy because the metal is vaporized in a certain weird way, and more of that if you take my physical science class. Back up, not safe over here. All right, let me put the potassium in.
On the floor.
Back up, back up, back up. Alistair, get off the stage, Alistair. All right, back up. Now I'm going to put the sodium in. We'll see what that does, okay? Stand by and...
It looks like a fire.
Back up. Stay back. Now sodium, you got to be careful with. Sodium is one of the more unpredictable ones. Oh, well, here's what happened. It jumped out of the water and became a piece of molten metal on my desk. See that? Molten. Back up. Back up. Alistair, out of the shot. Back up. Back up. Alistair, this is about to get really dangerous. Back up. Get out of the shot. Okay, way back. Because I'm way back. Alistair. Out of the shot. Okay, here we're going to go. It's going to go again. Get out of here, Alistair.
Wow. Whoa, I think those are fire.
Woo!
Wow.
So, I think with that, we've illustrated how alkali metals are different from other metals, and also why maybe you got to be careful when you do experiments like this with small children around. All right, I hope you've enjoyed this video. You love this experiment?
I love it. I love it. I love it. Love it. I love it.
Have a nice day. Bye-bye.